Look up at the night sky, and you'll see Earth's moon glowing like a silent sentinel, familiar, constant, almost comforting. But what if I told you our moon is just one of hundreds lurking in the shadows of our solar system, each hiding secrets so bizarre they defy imagination? Beyond Earth, moons aren't just dull, rocky spheres, they're volcanic hellscapes, ice-covered oceans, even worlds with skies thicker than our deepest oceans. Some scream with geysers taller than skyscrapers, while others might hide lakes of bubbling methane or clues to life itself. Think about that for a moment. Right now, as you're watching this, there's a moon out there where it rains gasoline, another where the ground is cracked like a jigsaw puzzle, oozing what scientists suspect could be alien microbes. There's even one that shouldn't exist at all, a moon orbiting backward, defying every rule of gravity. These aren't just celestial oddities, they're windows into the universe's wildest creativity. And the craziest part, we've barely scratched the surface of what's out there. So let's embark on a journey together, a tour of the 25 most jaw-dropping, head-scratching moons in our cosmic neighborhood. We'll uncover geysers that blast water into space, ice shelves hiding oceans twice the size of Earth's, and volcanic eruptions so violent they'd make Mount Vesuvius look like a campfire. By the time we're done, you'll see our solar system not as a quiet, predictable place, but as a theater of wonders, where moons aren't just rocks, but characters in a story far stranger than fiction. Ready? Let's dive in. Io is not just another moon, it's a cosmic pressure cooker, a world where the ground itself is alive with fury. Picture this, a moon so restless that its surface reshapes itself constantly, spewing lava fountains dozens of miles high, painting the sky in shades of sulfur yellow and molten red. This is Jupiter's innermost large moon, and it holds a title no other celestial body can claim, the most volcanically active place in the entire solar system. What drives this relentless firestorm? Blame Jupiter's overwhelming gravity. Io is caught in a gravitational tug of war, not just with the gas giant, but with its neighboring moons Europa and Ganymede. This constant stretching and squeezing, called tidal heating, generates so much friction inside Io that its interior stays molten, fueling hundreds of active volcanoes. Some of these eruptions are so powerful they've been spotted by telescopes on Earth, blasting material high above the moon's thin atmosphere. And then there's the sulfur. Rivers of it flow across Io's surface, pooling in vast lakes of molten rock. The plumes from its volcanoes carry sulfur dioxide so far into space that they've created a donut-shaped ring of charged particles around Jupiter itself. Even the moon's surface color, a psychedelic patchwork of yellows, oranges, and whites, comes from sulfur compounds constantly being recycled by eruptions. NASA Galileo spacecraft gave us our closest look at this hellish landscape, revealing lava flows longer than the Grand Canyon and calderas so deep they could swallow entire cities. But perhaps the most mind-bending discovery, Loki Patera, a lava lake roughly the size of Lake Ontario, where the crust breaks apart and reforms like a slow-motion conveyor belt of fire. Io doesn't just defy expectations, it shatters them. While most moons are frozen relics of the solar system's past, this one burns with the energy of a world still being born. It's a reminder that even in the quiet vastness of space, some places refuse to stay still. Beneath Europa's frozen crust lies one of the most tantalizing mysteries in our solar system, an ocean. Not just any ocean, but a global saltwater sea, hidden under miles of ice and holding more liquid water than all of Earth's oceans combined. This isn't science fiction. It's real, and it's why scientists believe Jupiter's fourth largest moon might be our best shot at finding life beyond our planet. Look at Europa through a telescope, and you'll see a world that looks like a cracked eggshell, a labyrinth of reddish-brown streaks crisscrossing its gleaming surface. These fractures aren't random. They're evidence of a dynamic, shifting ice sheet flexed and strained by Jupiter's relentless gravity. Some ridges rise taller than the Himalayas, while others stretch for thousands of miles, as if something beneath the ice is pushing, twisting, reshaping this frozen skin from below. And what's beneath that ice? An ocean kept liquid by the same tidal forces that turn Io into a volcanic inferno. But here, that energy doesn't produce lava. It might be fueling hydrothermal vents, superheated jets of mineral-rich water erupting from the seafloor. Sound familiar? On Earth, these vents are oases of life, supporting ecosystems that thrive in total darkness. That's why Europa's ocean isn't just water. It's a potential cradle for alien microbes or even something more complex. The clues don't stop there. Plumes of water vapor have been spotted erupting from Europa's south pole, shooting material hundreds of miles into space. NASA Galileo spacecraft detected a weak magnetic field, further hinting at a salty, conductive ocean beneath the ice. And those reddish streaks, they might be deposits of sea salt mixed with organic compounds, stains left behind as liquid water from below oozes up through cracks and freezes on the surface. That's why missions like Europa Clipper have scientists on the edge of their seats. Slated to launch in 2024, this robotic explorer will orbit Jupiter and make dozens of close passes over Europa, mapping its ice shell, analyzing those mysterious plumes, and even tasting ejected particles to search for organic molecules. If there's life there, we might not need to drill through miles of ice to find it. Europa could be handing us the evidence on a silver platter. Imagine standing on that frozen surface. The ice beneath your feet could be thin in spots, barely a few kilometers thick. Below, an abyss of dark water stretches deeper than the Mariana Trench, warmed by unseen vents, swirling with currents we can barely fathom. It's a world where life could exist in utter darkness, powered not by sunlight, but by the raw chemistry of water and rock. That's Europa, not just a moon, but a promise, a question waiting to be answered. Ganymede isn't just another moon, it's a cosmic heavyweight, a world so massive it dwarfs Mercury and Pluto, yet it orbits Jupiter like a silent titan wrapped in ice. This is the largest moon in our solar system, so big it could be considered a planet if it didn't revolve around a gas giant instead of the sun. But size isn't its only claim to fame. Ganymede hides secrets beneath its frozen shell that make it one of the most fascinating places beyond Earth. First, there's the magnetism. Unlike any other moon, Ganymede generates its own magnetic field, a rare feat that even Mars can't match. Scientists believe this magnetic shield comes from a churning, molten core of liquid iron, hidden deep beneath layers of rock and ice. Imagine that, a moon with a dynamo of its own, creating invisible lines of force that stretch out into space, dancing with Jupiter's colossal magnetic field in an endless cosmic tug-of-war. Then there's the surface. Ganymede's ancient face tells a story billions of years old, scarred by countless asteroid impacts. Some regions look like a battered relic of the early solar system, while others reveal bizarre, grooved terrain, long, parallel ridges and troughs stretching for hundreds of miles, as if the moon's crust was stretched and torn apart like taffy. No one knows exactly how these grooves formed, but one theory suggests they're the scars of tidal forces, a time when Ganymede's orbit shifted and its icy shell cracked under the strain. But the biggest enigma lies beneath. Just like Europa, Ganymede likely harbors a vast ocean of liquid water, sandwiched between layers of ice and rock. Recent flybys by NASA Juno spacecraft detected strange fluctuations in Ganymede's magnetic field, hinting at a salty, conductive layer, possibly an underground sea. Unlike Europa's ocean, though, Ganymede's might be stacked in multiple layers, with ice and liquid alternating like a celestial layer cake. Juno's close pass in 2021 gave us our best glimpse yet, capturing stunning images of Ganymede's dark and bright terrains, its eerie lack of atmosphere, and even the subtle glow of auroras near its poles, caused by particles trapped in its magnetic field. But the real treasure, data suggesting that Ganymede's ocean could contain more water than all of Earth's oceans combined. Think about that for a second. A moon with its own magnetic shield, grooved landscapes that defy explanation, and an ocean hidden so deep it might as well be another world. Ganymede isn't just a moon, it's a planetary puzzle, a reminder that even in our own cosmic backyard, the line between moon and planet is thinner than we ever imagined. Callisto stands apart from the other Galilean moons, not for what it is, but for what it isn't. Unlike volcanic Io, Europa's fractured ice shell, or Ganymede's magnetic mysteries, Jupiter's second largest moon is a time capsule, a frozen record of the solar system's most violent era. Its surface is the most heavily cratered in the entire solar system, pockmarked with scars from asteroids and comets that have battered it for billions of years. This isn't just a moon, it's a celestial museum preserving the chaos of the early solar system in a way no other world does. Take a close look at Callisto's face and you'll notice something startling: nothing. No volcanoes, no geysers, no shifting tectonic plates. Its ancient crust has stayed frozen and rigid for eons, with no internal engine to reshape it. While Io roasts under Jupiter's gravitational grip, Callisto barely feels the heat. It orbits farther out, avoiding the tidal forces that turn its siblings into dynamic worlds. That distance makes it a fossil, a relic from a time when the solar system was still settling into place. But here's the twist: Callisto might not be as dead as it seems. Beneath that battered shell, some scientists suspect a hidden ocean, a layer of liquid water trapped between layers of ice and rock. Unlike Europa's global sea or Ganymede's layered depths, this one would be isolated, perhaps kept liquid by antifreeze salts or residual heat from radioactive decay. The Galileo spacecraft detected subtle distortions in Jupiter's magnetic field near Callisto, hinting at a conductive layer. Maybe not a churning, Earth-like ocean, but something far stranger, a sluggish, briny slush sealed away in darkness. What's even more puzzling is why Callisto lacks tidal heating. Europa and Ganymede dance in orbital resonance with Io, their gravity tugging on each other and generating internal friction. Callisto, however, orbits alone, never quite syncing up with the others. It's the odd moon out, a silent observer of its siblings' geological drama. Imagine standing on Valhalla, Callisto's largest impact basin, a bullseye of concentric rings stretching nearly 2,000 miles across. The ground beneath you hasn't changed since the solar system was young. The distant sun is just a bright star, and Jupiter looms motionless in the sky, its storms swirling but never touching this frozen world. Callisto doesn't just show us where the solar system has been, it makes us wonder what else might be hiding in the dark. Now we come to one of Jupiter's strangest little oddballs, Amalthea, a moon that looks less like a celestial body and more like a cosmic potato someone forgot to shape. This tiny, reddish world barely stretches 50 miles across, yet it packs more mysteries than some planets. What makes it so bizarre? For starters, its shape. While most moons are roughly spherical, Amalthea is lumpy and elongated, as if sculpted by a careless hand. Scientists think it might be little more than a pile of rubble loosely held together by gravity, a fragile relic from the solar system's chaotic early days. Then there's the color. Amalthea's surface glows a deep, rusty red, a hue that comes from sulfur dust blasted off Io's volcanoes and trapped in Jupiter's powerful magnetic field. Picture this: every time Io erupts, it spews sulfur dioxide into space, and some of that material gets swept up by Amalthea, painting its surface over millennia like cosmic graffiti. But that's not the only thing Amalthea steals from its neighbors. This little moon acts as a shepherd, herding particles from Jupiter's faint rings, guiding them into neat orbits with its subtle gravity. Without Amalthea, those rings might not exist at all, yet the real head-scratcher is the heat. For such a small, distant moon, Amalthea radiates more warmth than scientists can explain. Some theories suggest it's absorbing energy from Jupiter's magnetic field, while others propose tidal flexing, though nothing like the extreme forces that power Eo's volcanoes. Whatever the source, Amalthea glows faintly in infrared, a tiny ember in the vast cold of space. NASA Galileo spacecraft gave us our closest look, revealing a surface pitted with craters and grooves, possibly from ancient impacts that nearly shattered this fragile world. But here's the kicker: Amalthea's density is shockingly low, lower than water ice. That means if you could drop it into a giant cosmic bathtub, it would float. This moon isn't just odd. It's a puzzle wrapped in a riddle, a reminder that even the smallest worlds can defy expectations. So next time you think of Jupiter's moons, don't just picture the giants like Europa and Ganymede. Remember Amalthea, the tiny, misshapen underdog, bathed in stolen sulfur, glowing with unexplained heat, and quietly shaping the rings of the solar system's largest planet. Sometimes the quietest players hold the strangest secrets. Among Jupiter's vast collection of moons, Himalaya stands out as a cosmic hitchhiker, a rogue traveler snatched from the depths of space. This isn't a world born in Jupiter's orbit but a captured asteroid, an ancient wanderer pulled in by the gas giant's overwhelming gravity. Darker than charcoal and lumpy in shape, Himalaya belongs to Jupiter's irregular moon family, a group of misfits with tilted, chaotic orbits that scream outsider. Unlike the Galilean moons with their neat, circular paths, Himalaya follows a skewed, elliptical route, swinging around Jupiter at a steep angle. Its orbit is so erratic that astronomers suspect it wasn't part of the original Jupiter system at all. Instead, it likely drifted too close billions of years ago, caught in a gravitational trap it could never escape. But how does a planet steal a moon? Picture the early solar system, a cosmic free-for-all where asteroids and small worlds crisscrossed unstable orbits. Jupiter, with its immense pull, could have snagged Himalaya as it passed by, slowing it down just enough to bind it permanently. The same fate might have befallen dozens of other irregular moons, now trapped in Jupiter's gravitational web like flies in amber. Then there's the surface, a battered relic untouched by geologic activity. Himalaya's dark, carbon-rich crust is pocked with craters, some so large they nearly shattered this fragile world. Observations from Earth-based telescopes and NASA Cassini spacecraft reveal a surface that reflects barely 3% of sunlight, making it one of the darkest objects in the solar system. That darkness hints at a primitive composition, unchanged since the dawn of the solar system, a time capsule of the raw materials that built the planets. Yet Himalaya's most intriguing feature might be its family ties. It's the largest member of a group of moons sharing similar orbits, all likely fragments from a single, larger asteroid that shattered in a collision long ago. These siblings travel together like a cosmic gang, bound not just to Jupiter but to each other by their shared origin. It's a reminder that even in Jupiter's court of captured wanderers, some moons carry the scars of their violent past. So next time you gaze at Jupiter, remember, not all its moons are native. Some, like Himalaya, are interlopers, silent witnesses to the chaos of the early solar system, frozen in orbits that whisper tales of capture and survival. They're proof that even the king of planets doesn't always play fair. Step onto Titan and you might forget you're standing on a moon at all. This isn't just another frozen rock. It's a world with its own weather, its own rivers, even its own version of beaches. Saturn's largest moon is the only place in the solar system besides Earth with liquid pooling on its surface, though you wouldn't want to swim in it. Instead of water, Titan's lakes and seas brim with methane and ethane, hydrocarbons so cold they flow like molasses in a landscape straight out of a sci-fi dream. What makes Titan truly extraordinary is its atmosphere, a thick, hazy blanket of nitrogen laced with organic compounds, towering hundreds of miles above the surface. It's so dense that standing on Titan would feel like standing at the bottom of Earth's ocean. the air pressing down with 1.5 times the pressure we're used to. And just like Earth, Titan has seasons, storms, and even rain. But here, the raindrops aren't water, they're liquid methane falling lazily from orange-hued clouds and carving river valleys into icy bedrock. The parallels don't stop there. Titan boasts sprawling dune fields, not of sand but of hydrocarbon grains, sculpted by winds into waves taller than the Great Pyramids. It has mountain ranges made of water ice, harder than granite at Titan's frigid temperatures. And then there's the lakes, some as small as ponds, others like Kraken Mare, a sea larger than the Caspian, where methane waves might lap against shores of frozen organic sludge. NASA Cassini mission gave us our first close-up look, piercing Titan's haze with radar to reveal a shockingly Earth-like world. But the real game-changer is Dragonfly, a nuclear-powered drone set to launch in 2027. This rotorcraft will hop across Titan's surface, sampling its chemistry, sniffing the air, even landing near Selk Crater, where scientists suspect water once mixed with organic molecules. Why does that matter? Because Titan's environment, rich in carbon, nitrogen, and liquid, mirrors the primordial conditions that sparked life on Earth. Its methane cycle acts like a cosmic lab, cooking up complex molecules that could teach us how life begins. Imagine discovering not just an alien world, but a recipe for life itself, written in the chemistry of an icy moon 1 billion miles away. Titan isn't just strange, it's a looking glass showing us what our own planet might have been long before the first microbes stirred. Enceladus doesn't just hide its secrets beneath the ice, it blasts them into space. This tiny moon of Saturn, barely 300 miles wide, is home to one of the most spectacular sights in the solar system. Towering geysers of water vapor and ice erupting from its south pole like a cosmic fountain. These plumes shoot hundreds of miles into the void, carrying with them particles from a hidden ocean, an ocean that might just hold the ingredients for life. The discovery came as a shock. When NASA Cassini spacecraft first spotted these jets in 2005, scientists expected Enceladus to be just another frozen ball. Instead, they found a world alive with activity, its surface scarred by massive cracks nicknamed tiger stripes. These fractures aren't just blemishes, they're the vents of a subterranean sea, where liquid water under immense pressure forces its way through the icy crust, creating plumes so vast they feed Saturn's entire E-ring with fresh ice particles. But the real bombshell came when Cassini dove through those plumes, sampling their composition. The spacecraft detected molecular hydrogen, carbon dioxide, and even organic compounds like methane, chemical signatures that, on Earth, often point to hydrothermal activity on the seafloor. That's when the pieces clicked. Enceladus isn't just wet, it's warm. Deep below its icy shell, hot rock meets ocean water, possibly through vents similar to those that nurture life in Earth's darkest ocean trenches. The math is staggering. Enceladus's ocean glows with more hydrothermal energy than anyone predicted, enough to power entire ecosystems. Its plumes contain silica nanoparticles, a telltale sign of water interacting with rock at temperatures nearing 200 degrees Fahrenheit. And then there's the salt. The ice grains Cassini analyzed were laced with sodium chloride, the same stuff that makes our oceans salty, hinting at a global sea in constant contact with a rocky core. This moon doesn't just tease us with the possibility of life, it hands us a roadmap. Those plumes are free samples, ejecting material from the ocean below without the need for drills or landers. Future missions could fly through them, analyzing their chemistry for amino acids or even cellular structures. Imagine, we might not need to dig through miles of ice to find extraterrestrial life. Enceladus could be delivering it straight to us, one geyser at a time. Stand on its surface near the South Pole, and you'd witness a spectacle unlike anything on Earth. Walls of ice rise like shattered glass, while plumes of vapor arc overhead, catching the faint sunlight in a perpetual shimmer. Beneath your feet, an ocean churns in eternal darkness, its depths warmed by the moon's restless core. Enceladus isn't just a moon, it's a promise, a tiny world with the audacity to suggest that life might not be unique to Earth after all. Iapetus doesn't just orbit Saturn, it wears a cosmic disguise, a two-faced mask that baffled astronomers for centuries. One hemisphere gleams as bright as freshly fallen snow, while the other side is stained a deep, inky black like a moon dipped in tar. This stark dichotomy earned it the nickname Saturn's yin-yang moon, but the real mystery isn't just its appearance, it's how such a dramatic split could exist in the first place. Take a closer look at that dark terrain, nicknamed Cassini Reggio after the astronomer who first spotted the moon's strange duality in the 1600s. The material coating it isn't just dark, it's eerily uniform, thinning out near the borders like paint brushed onto a spinning sphere. Early theories suggested volcanic activity, but the truth turned out to be far more bizarre. The leading hypothesis, Iapetus is a cosmic vacuum cleaner, collecting dust from Saturn's distant, irregular moon Phoebe. As Phoebe's orbit is bombarded by micrometeorites, it sheds dark debris that spirals inward, plastering itself onto Iapetus's leading face like bugs on a windshield. Over eons, this accumulated grime absorbed just enough sunlight to warm the surface, triggering a feedback loop where ice sublimated away, leaving behind even more concentrated darkness. But the peculiarities don't stop there. Stretching like a seam around Iapetus's equator is a towering ridge that defies easy explanation. This mountain chain rises 12 miles high in places 3 times taller than Mount Everest and runs perfectly along the equator for over 800 miles. Some scientists argue it's the frozen remnant of a ring system that collapsed onto the moon's surface, while others propose it formed during a dramatic slowdown in Iapetus's rotation, causing its crust to buckle. Then there's the wilder idea that the ridge is the scar of an ancient, moon-spanning impact, a cataclysm so violent it reshaped the entire world in an instant. Even the bright terrain holds puzzles. Unlike the pristine ice of Saturn's other moons, Iapetus's white regions are laced with a reddish tint, possibly organic compounds mixed with ice. And because the moon's rotation is tidally locked, one face always leads into its orbit, eternally collecting dark material while the trailing hemisphere stays clean, frozen in perpetual contrast. Stand on the ridge at dawn and the view would be surreal. To one side, a blinding expanse of ice stretching toward the horizon, to the other, an abyss of darkness swallowing the light. Above, Saturn's rings would slice the sky in a razor-thin arc, a silent witness to a moon that refuses to conform. Iapetus isn't just odd, it's a planetary crime scene, a place where the forces of dust, ice, and time colluded to create something no one saw coming. Hyperion looks like the universe played a prank on physics, a moon shaped like a crumbling sponge, tumbling through space with no regard for order. Unlike Saturn's other moons, with their smooth ice or jagged ridges, Hyperion is a cosmic shard of Swiss cheese, pitted with deep, irregular craters that give it a bizarre, hole-riddled texture. The first time scientists saw close-up images from the Cassini spacecraft, they couldn't believe their eyes. This wasn't just a battered world, it was a celestial anomaly, defying every expectation of how a moon should look or behave. Then there's the rotation, or lack thereof. Hyperion doesn't spin predictably like Earth or even wobble like a top. It tumbles chaotically, flipping end over end in a drunken orbit, its axis shifting unpredictably under the gravitational tug of Saturn and its larger moon, Triton. One day on Hyperion could last weeks, only to suddenly shorten or lengthen without warning. This isn't just irregular rotation, it's orbital anarchy, a dance so erratic that astronomers still struggle to model it accurately. But the weirdness runs deeper. Hyperion's density is so low that it's likely more empty space than solid matter, a fragile, porous structure that might collapse if you stepped on it. Scientists suspect it's a rubble pile held together loosely by gravity, a Frankenstein's monster of ice and rock assembled from ancient collisions and those eerie craters. Their floors are coated in a mysterious dark material, a substance rich in organic compounds that absorb sunlight like cosmic charcoal. Some researchers think it's the same stuff coating parts of Iapetus, possibly delivered by the same dust cloud from Phoebe. But on Hyperion, the dark sludge seems concentrated in the bottoms of craters, as if it pooled there like spilled ink. Voyager 2 first glimpsed Hyperion's jagged silhouette in 1981, but it was Cassini that revealed the moon's true strangeness. Flying just over 300 miles from its surface in 2005, the spacecraft captured details of its honeycombed terrain, where crater walls rise like jagged cliffs and sunlight filters through gaps in the icy lattice. In some spots, the surface is so porous that impacts might have shattered straight through, leaving behind caverns rather than traditional craters. Imagine floating above this surreal landscape. The ground beneath you looks like it's been hit by a celestial shotgun blast, each cavity revealing shadows that stretch deeper than they should. The dark stains in the craters glow faintly, as if something, whether chemistry or some unseen process, is reacting to the faint sunlight. Hyperion doesn't just challenge our ideas of what a moon should be, it shreds them, proving that even in a solar system full of oddities, some worlds refuse to follow the rules. Phoebe doesn't just orbit Saturn, it defies it, moving backward against the flow like a cosmic rebel with a story to tell. While most of Saturn's moons dance in neat, orderly circles around the planet's equator, Phoebe races in the opposite direction, its tilted, chaotic path screaming outsider. This isn't just a quirk, it's a clue. Scientists are convinced Phoebe didn't form here at all. It's a stolen world, a wanderer from the distant Kuiper belt, snatched by Saturn's gravity billions of years ago and forced into a life of orbital exile. And what a world it is! Voyager 2's grainy images first hinted at Phoebe's secrets, but NASA Cassini spacecraft gave us the full picture, a dark, cratered landscape speckled with bright ice like chocolate dusted with powdered sugar. This moon reflects just 6% of sunlight, making it one of the darkest objects in the solar system. Yet in those shadows, Cassini spotted something astonishing: water ice, exposed in fresh scars where impacts gouged the surface. That ice shouldn't survive so close to the sun, which means Phoebe's interior might still be primordial, a frozen relic of the solar system's infancy. But here's where the story gets even wilder. Phoebe isn't just a passive captive, it's a cosmic polluter. As micrometeorites bombard its surface, they kick up dark dust, sending it spiraling inward toward Saturn. Some of that debris eventually smears across the face of Iapetus, creating its infamous two-toned appearance. Other particles might have even delivered water to Saturn's inner moons, seeding them with the ingredients for subsurface oceans. Think about that, a rogue moon hurling ice and organic molecules into the void, potentially shaping the chemistry of an entire planetary system. Then there's Phoebe's composition. Cassini's instruments detected carbon dioxide, minerals like phyllosilicates, and organic compounds, materials common in the outer solar system but rare near Saturn. Its density suggests a rocky core wrapped in ice, another hallmark of Kuiper belt objects. Some researchers believe Phoebe could be a cousin of Pluto, a refugee from the same icy neighborhood, now trapped in Saturn's gravitational grip. Stand on Phoebe's surface and the view would be surreal. Saturn hangs low on the horizon, its rings edge on and faint, while the sun is just a bright speck in a sea of stars. The ground beneath your feet is porous, pitted with ancient craters, their walls streaked with ice that survived billions of years in the darkness. This isn't just a moon, it's an artifact, a piece of the solar system's lost history, orbiting backward as if refusing to forget where it came from. Mimas doesn't just orbit Saturn, it stares back at us like a cosmic eye, its surface dominated by a crater so colossal it transforms the entire moon into a dead ringer for the Death Star. Herschel crater spans 80 miles across, nearly a third of Mimas's diameter, with walls towering over 3 miles high and a central peak that juts upward like a frozen tidal wave. One slightly larger impact, and this moon might not have survived at all. But what's even more surprising than its appearance is the growing suspicion that Mimas might hide a secret beneath its battered shell, an ocean of liquid water, defying every expectation for such a tiny, frozen world. For decades, scientists dismissed the idea outright. Mimas is just 250 miles wide, barely large enough to hold itself together under gravity. Its surface is rigid, lacking the telltale cracks and geysers seen on Enceladus or Europa, and its orbit doesn't experience the extreme tidal heating that fuels those moons' subterranean activity. Yet in 2014, researchers poring over Cassini spacecraft data noticed something odd. Mimas wobbles. Its rotation isn't perfectly steady, suggesting either a misshapen core or, more intriguingly, a global ocean sloshing beneath the ice, uncoupled from the outer shell like yolk inside a spinning egg. The debate hinges on tidal forces. Saturn's gravity stretches and compresses Mimas as it orbits, but at first glance, the math doesn't add up. The moon's distance from Saturn means it shouldn't experience enough tidal heating to keep water liquid. But here's the twist. Mimas might have once shared an orbital resonance with another moon, a gravitational tug of war that pumped extra energy into its interior. Even if that resonance faded, the heat could linger, trapped under an insulating layer of ice for billions of years. Or perhaps radioactive decay in its core provides just enough warmth to maintain pockets of liquid beneath Herschel's frozen sky. Then there's the crater itself, a clue to Mimas's past. The impact that created Herschel should have shattered the moon, yet it survived. Some scientists argue that a subsurface ocean at the time could have absorbed the shock, acting like a cushion to prevent total disintegration. Others counter that Mimas's rigid ice was simply thick enough to withstand the blow. The truth might lie in future missions, equipped with ice-penetrating radar to peer beneath the surface and settle the debate once and for all. Stand on the rim of Herschel crater and the view would be staggering. The central peak rises like a frozen skyscraper, casting shadows across a bowl so vast its curvature would warp your perception of the horizon. Below your feet, the ice could be hiding an ocean, or it might just be a silent, frozen tomb, a reminder of how little we truly know about these distant worlds. Mimas doesn't just challenge our assumptions, it dares us to look deeper, proving that even the smallest moons can hold the solar system's greatest surprises. Miranda looks like a moon that was shattered and hastily glued back together by a reckless cosmic hand. Of all the moons in our solar system, none wear their violent history as plainly as this fractured world orbiting Uranus. When Voyager 2 raced past it in 1986, the images stunned scientists. Here was a moon with terrain so chaotic it defied explanation. Towering cliffs loom higher than Mount Everest, plunging into valleys deeper than the Grand Canyon. Jagged ridges slice across the surface like scars, while strange, oval-shaped features called coronae bulge outward like frozen blisters. This isn't geology, it's planetary pandemonium frozen in time. What could have caused such madness? The leading theory points to catastrophe, either a colossal impact that nearly shattered Miranda, or tidal forces so intense they ripped the moon apart multiple times. Picture this: early in its life, Miranda might have been a quiet, icy sphere, but Uranus's gravity, combined with the tug of other moons, could have stretched and squeezed it like putty, generating enough heat to melt its interior. Over time, denser material sank toward the core, while lighter ice rose to the surface, fracturing the crust into the bizarre patchwork we see today. Some researchers suggest Miranda might have been smashed apart by impacts and reassembled multiple times, each collision leaving behind another layer of jumbled terrain. The coronae are the crown jewels of this chaos. These sprawling, racetrack-shaped regions, Verona Rupes, Arden Corona, and Inverness Corona, are unlike anything else in the solar system. Their grooved surfaces ripple in concentric patterns, as if the ground itself was kneaded like dough. One hypothesis claims they're the scars of ancient upwellings, where warm ice from Miranda's interior punched through the crust before freezing solid. Others argue they're the remnants of massive landslides, triggered when parts of the moon's surface collapsed under gravitational stress. Then there's the cliffs. Verona Rupes isn't just a cliff. It's the tallest known in the solar system, with a sheer drop of over 12 miles. If you stood at its edge, the fall would last nearly 12 minutes before you hit the bottom. The only reason you wouldn't see the curve of the moon from that height, Miranda's tiny size, just 290 miles across, means the horizon would be unnervingly close, the landscape crumpling into view like a funhouse mirror. Voyager's grainy black and white images only tell part of the story. Without a follow-up mission, Miranda remains frozen in our imaginations, a world of extremes where geological forces ran wild with no one to witness them. Was it tidal forces, collisions, or some bizarre combination of both that shaped this place? For now, Miranda keeps its secrets, a jigsaw puzzle with half the pieces missing, daring us to return and uncover the truth buried beneath its fractured skin. Ariel gleams like a cosmic paradox, a moon that shouldn't look this young. While most of Uranus's moons wear the battered faces of ancient warriors, Ariel's surface tells a different story. Vast stretches of smooth, uncratered plains stretch across its icy shell, interrupted only by sprawling networks of canyons so deep they could swallow the Grand Canyon whole. This isn't the frozen relic we'd expect from a moon orbiting the solar system's icy outpost. It's a world that somehow rewrote its own history, erasing its scars with forces we're only beginning to understand. Those canyons, called chasmata, are the first clue to Ariel's turbulent past. Some stretch over 600 miles long, their walls sheer and jagged, as if the moon's crust was torn apart by a colossal grip. Unlike the haphazard fractures on Miranda, Ariel's chasms form intricate, branching patterns, suggesting they weren't born from random chaos but from something far more deliberate, liquid. Scientists suspect that long ago, watery eruptions, cryovolcanoes, might have burst through Ariel's icy surface, flooding low-lying regions before freezing solid. The smoother plains could be the remnants of those icy lava flows, resurfacing the terrain like a cosmic Zamboni smoothing over old wounds. But what fueled this activity? Here's where the mystery deepens. Ariel is too small to generate its own heat, and Uranus's tidal forces are weaker than Jupiter's or Saturn's. Yet something kept this moon warm enough to reshape itself long after its formation. One theory points to an ancient orbital dance, a gravitational tug-of-war with neighboring moons like Umbriel or Teutonia that stretched Ariel's interior, creating friction and melting its subsurface ice. Another possibility, radioactive decay in its rocky core, simmering just long enough to power a few 100 million years of geologic tantrums before finally flickering out. The contrast with Umbriel, Ariel's darker twin, couldn't be starker. Umbriel's surface is a bleak, cratered wasteland, its history frozen in time. Ariel, though, it gleams with hints of recent activity, its brighter ice reflecting sunlight like a freshly polished mirror. Even the canyon floors seem smoother than they should be, as if some slushy mixture of water and ammonia once oozed through them, softening the scars before freezing into oblivion. Stand on Ariel's surface and the view would be surreal. The sun, a mere pinprick, casts long shadows across those icy plains, while the canyon walls tower like skyscrapers of solid ice. In the distance, Uranus hangs motionless, a featureless blue marble against the stars. This moon doesn't just challenge our assumptions, it whispers of a time when even the coldest corners of the solar system could defy expectation, rewriting their stories in ice and fire. Umbriel lurks in the shadows of Uranus's moons, a charcoal-black enigma wrapped in cosmic silence. where Ariel dazzles with youthful plains and Miranda stuns with chaotic cliffs, Umbriel hides its secrets under a shroud of darkness, the darkest surface of any moon in its family. This isn't mere shadow, it's a uniform blanket of material so light-absorbing that even fresh craters barely gleam against the gloom. Only one feature pierces the veil, Wonder Crater, a solitary bright ring glowing like a ghostly halo on an otherwise pitch-black canvas. What paints Umbriel in such unrelenting darkness? The leading suspect is a sludge of ancient organic compounds, possibly delivered by impacts or volcanic plumes billions of years ago. Over time, radiation from Uranus's magnetosphere could have baked these carbon-rich molecules into a tarry crust, thickening with each eon until it smothered the moon's ice entirely. But here's the puzzle. Umbriel's twin, Ariel, shares the same environment, yet its surface shines far brighter. The difference might lie in Umbriel's lack of geologic drama. No cryovolcanoes to resurface it, no tectonic cracks to expose fresh ice, just a frozen stillness that let the darkness settle in like dust on an untended shelf. Then there's Wonder. This 90-mile-wide crater's brilliant rim defies Umbriel's monotony, its walls likely lined with water ice ejected during the impact. The contrast is jarring, a single flash of brightness on a moon that otherwise refuses to reflect light. Some scientists speculate Wonder's rays might stretch much farther than we can see, their faint traces swallowed by Umbriel's ever-hungry darkness. Voyager 2's fleeting glimpse in 1986 left more questions than answers. Why does Umbriel's crust lack the fractures seen on other Uranian moons? Could its interior still hide a long-dead ocean, frozen solid before it could reshape the surface? Or is this moon simply a relic, preserving the primordial grime of the early solar system like a fly trapped in amber? For now, Umbriel keeps its secrets close, a shadowy sentinel reminding us that some worlds prefer the dark. Titania reigns as the undisputed giant of Uranus's moon system, a world of dramatic cliffs, sprawling valleys, and whispers of hidden waters. Named after the queen of the fairies in Shakespeare's A Midsummer Night's Dream, this moon lives up to its mythical namesake with a landscape torn between beauty and violence. Voyager 2's flyby in 1986 revealed a surface scarred by colossal canyons, some stretching over 900 miles long and plunging twice as deep as the Grand Canyon. These aren't just cracks, they're gargantuan wounds in the moon's icy crust, evidence of a past where Titania's very backbone might have fractured under immense stress. What could have carved such monstrous valleys? The leading suspect is tectonics, not the slow, grinding plates of Earth, but a single, catastrophic event. Scientists suspect that as Titania's interior cooled billions of years ago, its water ice shell expanded, splitting the surface like an overfilled freezer tray. But there's a twist. Some of these chasms bear smooth floors, as if they were later flooded by slushy cryolava, a mix of water, ammonia, or even methane that oozed up from below before freezing solid. That smoothness hints at something even more tantalizing, a subsurface ocean long since frozen, but perhaps once warm enough to lubricate Titania's crust and fuel its geologic tantrums. Then there's the climate, or lack thereof. Titania orbits Uranus on its side, mirroring the planet's extreme axial tilt. For 84 Earth years, one pole bakes in perpetual sunlight, while the other sinks into frigid darkness. Temperatures swing between -300 and -370 degrees Fahrenheit, creating seasons so harsh they could snap steel. Yet even here, surprises lurk. During the long Uranian summer, solar radiation might vaporize trace methane or nitrogen ice, creating a whisper-thin temporary atmosphere, just enough to scatter sunlight into a pale blue haze before it's lost to the void again. But the real mystery is what lies beneath. Titania's density suggests a rocky core wrapped in a mantle of water ice with potential pockets of liquid trapped between layers. If remnants of that ancient ocean still cling to deep-sea vents shielded from the cold above, Could they have harbored chemistry ripe for life? It's a long shot, but in a solar system where Enceladus and Europa defy expectations, Titania reminds us that even the quietest moons might hide stories written in water and ice. Stand on the edge of Messina Chasmata, and the view would defy comprehension. The canyon walls rise like frozen tidal waves, their icy cliffs glowing faintly under a sun no brighter than a distant light bulb. Below, shadows pool so thick they seem bottomless, hiding valleys that haven't seen sunlight in decades. Titania isn't just Uranus's largest moon. It's a frozen archive of cosmic violence, a world that blurs the line between geologic spectacle and scientific enigma. Oberon guards the outer edges of Uranus's moon system like a frozen sentinel, its ancient face battered by billions of years of cosmic violence. Unlike its more dynamic siblings, this moon wears its age plainly, a world where time seems to have stood still since the solar system's earliest days. Craters blanket its surface so thickly that newer impacts often overlap older ones, creating a chaotic mosaic of collisions frozen in ice. But Oberon's real mystery lies in its dark stains, unexplained patches of Inkai materials smeared across its equator and pooling in crater floors, as if some cosmic hand dipped a brush in tar and flicked it carelessly across the moon's pale surface. Those dark patches have puzzled scientists since Voyager 2's fleeting visit in 1986. Some theories suggest they're deposits of carbon-rich gunk, possibly erupted from cryovolcanoes deep in Oberon's past. Others argue the material might be radiation-darkened organics, baked into a crust by Uranus's magnetosphere over eons, but the most tantalizing idea. These stains could be remnants of a subsurface ocean that once breached the surface, oozing methane or other hydrocarbons before freezing solid. The darkest concentrations cluster around a massive crater called Hamlet, a 20-mile-wide scar with a central peak that might have once acted like a volcanic vent, spewing dark sludge across the landscape. Then there's the terrain. Towering mountains rise near Oberon's south pole, some reaching heights rivaling Earth's tallest peaks, but made entirely of water ice as hard as granite. These jagged spines likely formed during colossal impacts, their material flung upward and frozen instantly in the moon's cryogenic temperatures. Between them stretch vast plains, smoother than much of Oberon's surface, hinting at possible resurfacing by ancient cryolava flows. What makes Oberon truly unique is its isolation. Orbiting nearly twice as far from Uranus as Titania, it's a world left to the cold and the dark, where temperatures hover near -400 degrees Fahrenheit. Sunlight here is 1,000 times weaker than on Earth, barely enough to cast dim shadows across its icy cliffs. Yet even here, surprises linger. Recent studies suggest Oberon's axis might have shifted long ago, tilting to expose once hidden deposits of volatile ices that could explain some of its bizarre surface features. Stand on the rim of Hamlet crater and the view would be surreal. The dark floor stretches like a frozen oil slick while the central peak glows faintly under the feeble sunlight. In the distance, Uranus hangs motionless, a blue-green disk ringed by darkness. Oberon doesn't just show us the solar system's past, it dares us to question how much we've missed in the quietest corners of space. Triton doesn't just orbit Neptune, it defies every rule in the cosmic playbook. This moon moves backward, spinning in the opposite direction of its planet's rotation, a celestial rebel with a past more violent than any other moon in our solar system. But Triton's rebellion runs deeper than its retrograde orbit. This world is a geological wildfire where nitrogen geysers blast 8 miles high, where the ground wrinkles into strange patterns nicknamed cantaloupe terrain, and where an icy surface hides the scars of a capture so brutal it might have shattered an entire sibling moon system. Let's start with that backward orbit, the telltale sign of a moon that wasn't born here. Triton's path is tilted, chaotic, and out of sync with Neptune's other satellites, screaming outsider. The prevailing theory, Triton once roamed the Kuiper belt as a dwarf planet, a sibling to Pluto, until Neptune's gravity reached out and snatched it billions of years ago. But the capture wasn't gentle. Triton likely barreled into Neptune's system at an angle, its gravitational interactions flinging other moons into space or plunging them into the planet itself. The cosmic violence didn't stop there. Neptune's tidal forces would have squeezed Triton like a stress ball, melting its interior and igniting volcanic activity that still shapes its surface today. And what a surface it is! When Voyager 2 flew past in 1989, it revealed a world of contradictions. Vast plains of frozen nitrogen stretch like glacial tundras, while geysers erupt with dark plumes of dust and gas painting streaks across the ice. These aren't your typical volcanoes. They're powered by sunlight heating subsurface nitrogen, creating pressure that blasts through cracks in the crust. But the real showstopper is the Cantaloupe Terrain, a sprawling region covered in dimpled, overlapping depressions unlike anything else in the solar system. Some scientists think these formations come from slushy ice oozing upward like blisters, while others argue they're the scars of ancient impacts that melted and refroze in strange patterns. Yet the most haunting detail isn't what Triton shows us, it's what awaits it. Neptune's gravity is still at work, slowly dragging Triton into a death spiral. In a few billion years, tidal forces will rip the moon apart, either scattering its debris into a new ring system or sending it crashing into Neptune in a final, cataclysmic embrace. Until then, Triton remains a frozen time capsule, a captured wanderer with a borrowed orbit, a violent history, and an expiration date written in the stars. Nereid doesn't just orbit Neptune, it carves a chaotic, lopsided path through space like a cosmic drunkard, swinging so close to its planet before veering wildly into the void that it holds the record for the most eccentric orbit of any moon in the solar system. At its closest, Nereid skims within 860,000 miles of Neptune. At its farthest, it catapults out to a staggering 5 million miles, a distance so vast it defies logic. This isn't just irregularity, it's orbital rebellion, a trajectory so extreme it screams of a violent past, one tangled with Neptune's gravitational tantrums and a possible showdown with its infamous moon, Triton. So how did Nereid end up on this roller coaster? The answer lies in Neptune's history of celestial upheaval. Unlike most large moons which settle into near-circular orbits, Nereid's wild path suggests it was yanked violently from its original course. The prime suspect, Triton's catastrophic arrival. When Neptune captured Triton from the Kuiper belt billions of years ago, the gravitational shockwaves would have been apocalyptic. Smaller moons were likely flung into new orbits, ejected into space, or even smashed into Neptune itself. Nereid, though, clung on but barely. Its erratic orbit could be the scar of that ancient gravitational battlefield, a survivor left tumbling in the wreckage of Triton's hostile takeover. But here's the twist: Nereid's orbit isn't just eccentric, it's unstable. Simulations suggest its path is still evolving, tugged by Neptune's gravity and Triton's domineering presence. Some astronomers argue it might eventually spiral inward, pulled to its doom, or be ejected entirely, cast adrift as interstellar flotsam. Others speculate Nereid could be a captured object itself, a refugee from the Kuiper belt that arrived around the same chaotic era as Triton but failed to settle into a stable home. Voyager 2's brief glimpse in 1989 revealed little, just a dim, irregular world no more than 200 miles wide, its surface likely a mix of water, ice, and rock. But Nereid's faint brightness variations hint at a slow, wobbly rotation, as if it's still reeling from whatever trauma shaped its orbit. Imagine standing on Nereid's surface. Neptune's disk would swell and shrink dramatically over time, sometimes dominating the sky, other times shrinking to a blue speck. The sun, a distant pinprick, its light too weak to cast shadows. This moon isn't just an oddity, it's a living record of Neptune's turbulent youth, a celestial survivor with a story written in the language of gravity and chaos. Proteus might not be Neptune's largest moon, but it wears its scars like a cosmic prizefighter. This isn't some smooth, polished world. It's a lumpy, misshapen chunk of ice and rock, barely held together by gravity and pockmarked with craters that tell a story of relentless punishment. The most dramatic of these scars, Pharos, a crater so massive it spans nearly half the moon's diameter, a gaping wound that should have shattered Proteus entirely. Yet here it is, defiantly orbiting Neptune like a battered bullet that refused to quit. What's most striking about Proteus isn't just its rugged appearance, it's the darkness. This moon absorbs 99% of the sunlight that hits it, making its surface one of the blackest known in the solar system. Stand on its terrain, and the ground beneath you would look like it's been smothered in cosmic charcoal, an inky expanse broken only by the occasional glint of ice exposed in fresh impacts. That darkness hints at a composition rich in organic compounds, possibly the remnants of ancient, carbon-rich materials that have been baked by radiation over billions of years. Now compare that to Triton, Neptune's other famous moon. Triton gleams like a frosty jewel, its surface reflecting 70% of incoming sunlight thanks to vast plains of fresh nitrogen ice. How can two moons orbiting the same planet look so radically different? The answer lies in their origins. Triton's brightness comes from its active geology geysers that spew fresh ice onto its surface, cryoval conos that resurfaced entire regions, while Proteus, locked in a quieter orbit, has been left to stew in its own darkness, its ancient crust untouched by renewal. But don't mistake stillness for simplicity. Proteus's irregular shape, barely spherical, more like a hastily assembled snowball, suggests it's a relic from the solar system's violent youth, a survivor of collisions that might have obliterated smaller moons. Some scientists even speculate that Neptune once had a more extensive moon system, shattered by Triton's catastrophic arrival, leaving Proteus as one of the last holdouts. Its craters, particularly Pharos, are like time capsules, preserving records of impacts that could rewrite our understanding of Neptune's chaotic early history. Voyager 2's flyby in 1989 gave us our only close-up of this enigmatic world, revealing a surface so rugged that it was initially mistaken for a pile of rubble. Yet despite its rough exterior, Proteus has a quiet dignity, a moon that's endured eons of bombardment without losing its place in Neptune's gravitational embrace. It might not have Triton's flashy geysers or retrograde orbit, but in its own way, Proteus is just as mysterious, a shadowy sentinel guarding secrets of the solar system's untamed past. Charon isn't just Pluto's moon, it's a cosmic dance partner, locked in a gravitational embrace so intimate they're practically two halves of the same world. Picture this: while most moons orbit their planets like distant attendants, Charon and Pluto whirl around a shared point in space, forever facing each other like mirror images. This tidal lock means if you stood on Pluto's surface, Charon would hang motionless in the sky. A silent sentinel looming larger than our own moon appears from Earth. And if you stood on Charon, Pluto would dominate the horizon, its icy plains and jagged mountains frozen in place, a perpetual eclipse of mutual devotion. But Charon's allure isn't just orbital poetry, it's geological chaos. Stretching across its rugged face is a canyon system, so vast it makes the Grand Canyon look like a scratch. Serenity Chasma, a gash in Charon's crust, plunges 4.5 miles deep and spans over 1,000 miles, long enough to stretch from New York to Chicago if it were on Earth. Scientists suspect this colossal rift formed as Charon's interior cooled, and its water ice crust contracted, splitting apart like an overfilled balloon left in the freezer. Yet the real shocker, some of these fractures might still be active, hinting at a world that hasn't fully settled into icy slumber. Then there's the color. While much of Charon's surface is a dull gray, its north pole wears a sinister red cap, a stain unlike anything else in the solar system. This isn't rust or iron oxide. Its tholins, complex organic molecules forged when methane gas escaping from Pluto's atmosphere gets zapped by ultraviolet light and cosmic rays, settling on Charon like cosmic graffiti. The result, a polar hood of reddish gunk, a chemical fingerprint of the two worlds' shared history. And what a history it is. The leading theory suggests Charon wasn't born alongside Pluto but forged in violence. Billions of years ago, a colossal impact between Pluto and another icy body likely shattered the dwarf planet, ejecting debris that coalesced into Charon. This would explain their eerily similar compositions and the odd tilt of their orbits, a celestial whiplash from the collision that birthed them. But here's the kicker: for a time, these two worlds might have shared more than just gravity. During their closest orbital points, some scientists speculate Pluto's tenuous atmosphere could have leaked onto Charon, creating a temporary bridge of nitrogen and methane between them. A ghostly whisper of gases passed like a shared breath before the cold vacuum of space tore them apart. Stand on Charon's cracked plains and the view would be surreal. Pluto's icy expanse would fill half the sky, its jagged mountains and frozen plains locked in perpetual stillness. Above, stars would wheel in slow motion, their light warped by Charon's thin haze of scattered molecules. This isn't just a moon, it's a testament to cosmic violence and gravitational harmony, a world that blurs the line between companion and counterpart. Charon doesn't just orbit Pluto, it completes it, a frozen yin to its celestial yang. Hydra and Nix might be Pluto's smallest moons, but they spin with the kind of chaos that defies all celestial norms. Imagine two cosmic tops flung into space, wobbling unpredictably as they orbit their dwarf planet. No steady rotation, no predictable rhythm, just pure, unfiltered celestial anarchy. These aren't the kind of moons you could set a watch by. Hydra somersaults like a drunk acrobat, completing one full rotation every 10 hours while taking 38 days to circle Pluto. Nix is even worse, tumbling so erratically that its poles and equator swap places mid-orbit. This isn't just irregular, it's orbital madness, a dizzying display of physics gone rogue. What makes these tiny worlds spin so wildly? The answer lies in their bizarre shapes and their gravitational tug-of-war with Pluto and Charon. Unlike spherical moons, Hydra and Nix are jagged lumps, Hydra resembling a stretched potato, Nix a misshapen pancake, and their uneven mass distribution turns them into cosmic tumbleweeds. But the real kicker is Charon. Pluto's giant moon is so massive that its gravity yanks on Hydra and Nix like an invisible puppeteer, disrupting their spins with every pass. The result, moons that don't just rotate, they flail, caught in a dance of perpetual imbalance. Then there's the brightness. For such small, dark bodies, Hydra and Nix reflect an astonishing amount of light, Hydra especially, gleaming like a frosty pebble in the void. New Horizons flyby in 2015 revealed surfaces coated in pristine water ice, far brighter than expected for objects so distant from the sun. Some scientists think this ice might be fresh, resurfaced by impacts or even cryovolcanic activity. Others argue it's a relic of their violent birth, a clue to their origins as shattered fragments of the same colossal collision that birthed Charon. Speaking of origins, Hydra and Nix are likely cosmic debris leftovers from the cataclysmic smash that shaped Pluto's entire system. Picture this: billions of years ago, a proto-Pluto slammed into another icy body, scattering rubble into orbit. The largest chunk became Charon, while smaller pieces clumped together to form Hydra, Nix, and Pluto's other tiny moons. Their chaotic spins, that's the lingering tremor of that ancient violence, a celestial hangover from the solar system's most dramatic demolition derby. Yet for all their chaos, these moons play a crucial role. Their orbits help scientists trace Pluto's gravitational history, revealing how the dwarf planet system evolved over eons. And their bright surfaces, their time capsules preserving ices that might hold secrets about the Kuiper Belt's primordial chemistry. Hydra and Nix might be small, but they're anything but quiet, two tiny testaments to the chaos and creativity of the cosmos. Dysnomia isn't just Eris's moon, it's the key that unlocked one of the biggest cosmic controversies of the 21st century. Before this tiny world was discovered, Eris was just another speck in the Kuiper belt, a distant object shrouded in mystery. But Dysnomia's orbit revealed something startling. Eris wasn't just big, it was denser than Pluto, a revelation that forced astronomers to rethink the very definition of a planet. The discovery sent shockwaves through the scientific community, stripping Pluto of its planetary title and rewriting the solar system's rulebook overnight. So how did this moon pull off such a cosmic coup by playing the role of celestial scale? Astronomers timed Dysnomia's 16-day orbit around Eris, using its motion to calculate the dwarf planet's mass with precision. The math didn't lie. Eris weighed in at nearly 27% heavier than Pluto, despite being slightly smaller in diameter. That extra heft came from rock. While Pluto is an icy sponge, Eris packs a rocky core beneath its frozen shell, a distinction that made it impossible to ignore. Dysnomia's silent dance became the evidence that shattered Pluto's planetary status, proving that size alone doesn't define a world. Yet for such a pivotal moon, Dysnomia remains eerily elusive. Observations suggest it's a dim, icy body, reflecting just 5% of sunlight, darker than asphalt, and likely no more than 150 miles across. Its surface might be primordial, untouched since the solar system's birth, a relic of the chaos that shaped the Kuiper belt. And here's the twist: Dysnomia's orbit is tilted at an extreme angle, suggesting a violent past. Most moons form alongside their parent worlds, but Dysnomia's skewed path hints it might be a captured fragment, a survivor of some ancient collision that left it forever bound to Eris. The irony: we know more about Dysnomia's gravitational influence than we do about its physical traits. No spacecraft has ever visited, and ground-based telescopes struggle to pierce the void between us. What little we've glimpsed comes from Hubble's aging eyes and indirect measurements, leaving its composition likely water ice laced with dark organic sludge open to debate. One tantalizing theory suggests Dysnomia could be a twin of Pluto's moon Hydra, another shredded remnant of the Kuiper belt's violent youth. Imagine standing on Eris's frozen plains. Dysnomia would hang motionless in the sky, a pitch-black speck against the stars, its orbit so distant it appears no larger than a pinprick. Yet without this unassuming moon, we might still be calling Pluto the ninth planet, oblivious to the hidden complexities of the solar system's frozen fringe. Dysnomia doesn't just orbit Eris, it holds the ghost of a cosmic revolution, a silent witness to the day our celestial neighborhood got a little less familiar and a whole lot more mysterious. Phobos and Deimos hang above Mars like cosmic omens, one racing toward its doom, the other drifting lazily into eternity. These aren't just moons, they're a study in contrasts, a pair of celestial siblings with fates as different as their faces. Phobos, the larger of the two, is a scarred, grooved mess, its surface etched with eerie parallel streaks that look like claw marks from some cosmic beast. Deimos, though, smooth, almost serene, its craters softened by time like an old stone worn by the wind. But the real drama isn't just how they look, it's where they're headed. Phobos is locked in a death spiral, creeping closer to Mars with every orbit, while Deimos is slowly slipping away, destined to become a lonely wanderer in the void. Let's start with Phobos, the doomed moon. Those grooves crisscrossing its surface, they're not random. Scientists once thought they were fractures from a colossal impact, the stress cracks of a moon tearing itself apart. But newer data suggests a wilder idea. These grooves might be tidal stretch marks, the result of Mars's gravity slowly pulling Phobos to pieces. Every 100 years, this moon orbits 6 feet closer to the planet. In 30 to 50 million years, it'll either smash into Mars in a fiery cataclysm or, more spectacularly, be shredded into a temporary ring, a gleaming halo of debris that'll rain down over millennia. That's why Phobos fascinates us. It's not just a moon, it's a time bomb. Deimos, meanwhile, plays the aloof sibling, smaller, smoother, and farther out. It's in no hurry to go anywhere. Its craters are buried under a blanket of dust, likely debris from asteroid impacts that settled over eons. Unlike Phobos's chaotic, potato-like shape, Deimos is more rounded, its surface less tortured by gravity's grip. But here's the kicker: Deimos is also drifting away, not toward Mars. At a glacial pace, yes, but over billions of years, it'll likely escape the planet's pull entirely, becoming a free-floating relic of the solar system's past. So where did these oddballs come from? The debate rages on. Their lumpy shapes and dark, carbon-rich surfaces scream captured asteroids, strays snagged by Mars's gravity from the nearby asteroid belt. But their near-circular orbits don't fit that story. Captured objects usually follow wild, lopsided paths. That's led to another theory. Maybe they're remnants of a colossal impact, debris blasted off Mars by an ancient collision, much like Earth's moon. Mars's surface even has a giant crater the right age to match, but the chemistry isn't perfect. Phobos and Deimos don't quite mirror Mars's composition, leaving the mystery wide open. Imagine standing on Mars's surface. Phobos would race across the sky 3 times a day, its irregular shape casting jagged shadows. Deimos, though, it'd crawl, taking 2.5 days to complete its leisurely trek. One moon a frenzied prisoner, the other a detached observer, both whispering secrets about Mars's violent past and uncertain future. Whether captured interlopers or shattered remnants, they're reminders that even the smallest worlds can hold the biggest questions. We know Earth's moon as a constant companion, a beacon in the night sky that feels almost timeless, but its story began with violence. Picture the solar system 4.5 billion years ago, a chaotic construction zone of colliding debris. Then a cataclysm, a Mars-sized object dubbed Theia, slammed into the young Earth with enough force to liquefy both worlds. Debris from the impact coalesced in orbit, forging our moon from molten rock in a matter of weeks. This giant impact hypothesis explains why lunar rocks share chemical fingerprints with Earth's mantle, yet lack volatile elements boiled away in that apocalyptic heat. The moon isn't just our neighbor, it's a piece of our planet's own flesh, hurled into the sky and frozen in time. But the moon's stillness is an illusion. Tidal locking ensures we only ever see one face, a quirk of gravity that slowed its rotation over eons until it matched its orbit. The far side, often mislabeled the dark side, gets just as much sunlight. It's simply hidden from view, a cosmic game of peekaboo played across billions of years. This asymmetry has consequences. The near side's thinner crust allowed ancient lava flows to create the dark seas we see today, while the far side remains rugged and battered, a testament to the moon's violent past. Yet even now, our moon refuses to be predictable. For centuries, observers have reported transient lunar phenomena, LTP, mysterious flashes, glows, and darkening patches that appear and vanish without explanation. Apollo astronauts witnessed them firsthand, describing streaks of light or color dancing across the surface. Some speculate these could be gas venting from underground, electrostatic discharges, or even meteorite impacts, but no theory fully explains them. NASA's Lunar Reconnaissance Orbiter has scanned these hotspots, yet the moon keeps its secrets. The next chapter is already being written. Artemis missions aim to return humans to the lunar surface by 2025, not just to plant flags but to stay. Proposed lunar bases could harness water ice trapped in permanently shadowed craters, converting it into oxygen and rocket fuel. These outposts might double as telescopes, shielded from Earth's radio noise by the moon's bulk, or as testing grounds for Mars missions. The moon isn't just a relic, it's a stepping stone, a laboratory, and perhaps one day a second home. Stand under its glow tonight and remember, this familiar disk is a world of fire and mystery, a silent witness to Earth's infancy and the key to humanity's future among the stars. Beyond the solar system's famous moons lurk forgotten oddities, worlds so small and strange they barely register as footnotes. Take Saturn's propeller moons, for instance, tiny lumps of ice named after aviation terms like Blériot and Earhart, their surfaces etched with bizarre wing-shaped grooves. These aren't craters or ridges, but disturbances in Saturn's rings, where the moon's gravity sculpts the surrounding particles into eerie, S-shaped wakes. They're not moons in the traditional sense, more like gravitational graffiti artists, their presence revealed only by the ripples they leave behind. Then there's Hippocamp, Neptune's cosmic afterthought. Smaller than New York City, this moon eluded detection until 2013, hiding in the glare of its larger sibling Proteus. But here's the twist: Hippocamp shouldn't exist. Its orbit is suspiciously close to Proteus, a moon so massive its gravity should have either swallowed Hippocamp or flung it into oblivion billions of years ago. The leading theory: Hippocamp is a celestial phoenix, a fragment chipped off Proteus during an ancient impact, now lingering like a ghost in its creator's shadow. Venture to Jupiter's outer reaches and the mysteries multiply. The gas giant's irregular moons names like Calm, Ananke, and Pasiphae orbit backward, their paths so tilted and elongated they resemble comets more than moons. These aren't native to Jupiter, they're likely captured asteroids or Kuiper Belt refugees, yanked into the planet's gravitational web during the solar system's chaotic youth. Some are so distant they take years to complete a single orbit, their surfaces darkened by eons of radiation into charcoal black relics of the early cosmos. And that's just what we've found. Astronomers estimate thousands more moonlets could be lurking in the solar system's outskirts, too faint or tiny for current telescopes to spot. Every time we improve our technology, every deeper sky survey, every sharper space probe, we uncover another handful. Some might be fragments of long-dead comets, others survivors of planetary collisions, their stories waiting to rewrite our understanding of how moons form. The universe has a habit of hiding its wildest secrets in plain sight, whispering that for every moon we know, a dozen more might be watching from the dark. From the lava-soaked plains of Io to the methane lakes of Titan, from the backward-spinning Triton to the two-faced enigma of Iapetus, these 25 moons have shattered every expectation of what a world can be. Think about it, we've got moons that spew water into space like celestial geysers, moons with underground oceans that could harbor alien life, even moons shaped like cosmic sponges tumbling chaotically through the void. And yet, for every mystery we've uncovered, a dozen more lurk in the shadows, waiting to upend everything we think we know. Take Europa. Beneath its icy shell, a global ocean churns, warmed by tidal forces we barely understand. But what moves beneath those dark waters? Could hydrothermal vents there brew the chemistry for life just as they do on Earth? Or consider Hyperion, that porous, tumbling oddball, why hasn't it shattered under its own instability? And what about Titan's eerie dunes, sculpted by winds we can't yet model, or the unexplained red stain on Charon's pole? Even our own moon, so familiar, still flashes with unexplained lights after centuries of observation. The truth is, we're only scratching the surface. These moons aren't just rocks, they're puzzles, each one holding clues to the solar system's wildest secrets. Some, like Enceladus, hand us free samples of their hidden oceans, while others, like Umbriel, guard their stories under layers of primordial darkness. And let's not forget the tiny rebels Hippocamp, Amalthea, hydra worlds so small they defy physics as we know it. Here's the kicker, we've barely visited most of them. A handful of robotic explorers have glimpsed their surfaces, but what waits beneath the ice, in the cracks of those canyon walls, or deep in their alien atmospheres? That's for future missions and future generations to uncover. So stay curious, look up at the night sky, and remember, every dot of light, every shadowed crater could be hiding a story stranger than fiction. Now it's your turn. Which of these moons captures your imagination? Is it Triton, the cosmic rebel doomed to spiral into Neptune, the Death Star-like gaze of Mimas? Or Europa with its silent, buried sea? Drop your favorite in the comments and let's keep the wonder alive. The solar system isn't done surprising us yet.